Am I on? Yeah, cool. Hey, everybody. Hope you're enjoying reInvent and appreciate you guys making it over to the win for our second session for ARC306. My name is John Fermento. I'm a principal solution architect on the resilience infrastructure and solutions team. For what it's worth, if any of you have heard of Application Recovery Controller, RAP53 Application Recovery Controller, my team builds that, and a new feature that we actually just released last night called Zonal Shift. So if you haven't heard about Zonal Shift, I'd recommend checking it out. It's pretty neat. So anyways, here with me today, I have Neeraj Kumar, who's a principal SA in AWS, and Barry Sheward, who's a chief architect with the Vanguard Group. So to kick it off, obviously we're here to talk about multi-region. I am curious to see, presumably 100% of the folks here are interested in it. How many are actively implementing multi-region today? Okay. And how many are implementing multi-region to achieve, say, like a RTO, RPO, they say less than 2 hours, so very strict requirements? Okay, cool, thank you. And I will say the majority of our presentation and what you'll see is kind of for that extreme use case, obviously applicable to others, but you'll get the gist in a couple minutes. So to kick it off, I'm going to be covering multi-region fundamentals. And this is kind of like a framework I've put together over the last 6 to 12 months of talking with customers on multi-region, and really want to create an easier way to think about some of the implications and trade-offs you need to make when thinking about multi-region, and just in general, a thought process for reasoning about multi-region and if it's right for your workload. Then I'll pass it over to Barry to talk about Vanguard's global multi-region strategy. And then Neeraj will wrap us up with like a broader array of more like active multi-region patterns we're seeing customers adopt. So to kick it off with the fundamentals, the first one is understanding the requirements. And it's almost like a prerequisite, really. And when talking with customers and going into meetings where we're talking about resilience or multi-region, I usually hear this statement right off the bat, like we need a multi-region architecture. And I always stop, I always have pause. It's like, maybe, it's definitely possible we may need that, but like first let's really understand the requirements. And I will say categorically, I have not come across an enterprise that every single application needs to be multi-region. So what we need to do is define requirements. And I see business and IT drive alignment via like tiering strategies like we see here. And I'm not saying this is like the best tiering strategy, it's more of a generic observation I put together from talking with customers. But one really important point to call out is the criteria component. And what I've seen work really well for that alignment between IT and business is really defining what is the criteria for platinum or tier 0. How much revenue loss is impacted by 5 minutes of downtime, or what if this application is down, is there some type of irreversible like brand damage to our company? That's just going to be a big hurdle to surmount if we can't get this application online. So having like clearly defined criteria and helping the teams understand like, hey, my application actually falls into that makes a world of a difference when reasoning about do I fall into this extreme resilience requirement that we need to think about multi-region. And the other key component to call is this is not a technology decision alone. There are cost and complexity, and you'll see that throughout this session today that multi-region is not necessarily an easy thing. And if done for the right reasons and done in the right way, it is beneficial for resilience and ensuring you can operate. But there are trade-offs, and there has to be alignment between business and IT. Like, hey, it makes sense for what we're trying to accomplish. So once you've went through that, you realize, we have this workload. It meets these requirements. We need to be able to fail over or run in another region in a very short amount of time, and we can't withstand an operational issue keeping us from running. Then we move to fundamental 2, and it's understanding the data. And the data is the most challenging part when it comes to multi-region. And I'm sure if the slew of hands at the beginning on multi-region, I'm sure everyone's heard of the CAP theorem. It's familiar. And I won't belabor it, but what it does is it gives us like a framework to reason about some of these challenges. And inherently with multi-region, we are accepting partition tolerance, right? We have these geographical dispersed implementations of our workloads. So what we need to do then is take a trade-off or be flexible on consistency or availability. And really what that comes down to is, what is our tolerance for asynchronous replication or synchronous replication? How are we getting that data from one region to another. So I put together this slide to really walk us through and give us an opportunity to think about like, how does each of these replication technologies and way to synchronize data impact the behavior of our applications, and how do we plan for each? So with asynchronous replication, the client is going to send a write to that data store in the primary region. It's going to get committed, and the client's going to get an acknowledgement, transaction's been committed, we're good to go. And then independently, that transaction will replicate to the database in the standby region. So what you can see here is there's a decoupled nature, right? There's no dependency on that transaction needing to be replicated across the board. It's also pretty performant because the client is making that write to the local database, committing and getting that acknowledgement pretty quickly. But what this does mean, if you look at, say, failure mode, right? So again, the client is writing that transaction. Now replication breaks for some reason. The client is still going to see that as potentially available, right? They're going to get a committed acknowledgement that that transaction's been committed. Everything looks good. And now if you were to fail over in this scenario, there's a high probability of any in-flight replication did not make it to that standby region. So now we have to think about, how do we get to a consistent state in that region when potentially we don't have all the data? And what we've seen customers do is create reconciliation processes where if you have a microservice architecture looking at decoupling via queues or streams and then replaying transactions throughout that chain to get to a consistent state. And even then, there is a probability that there still be some data not present. And I think the big distinction is the data is not necessarily lost, but it's definitely a probability of not being available until that primary comes back online and you could reconcile between the two. So now if we flip and look at synchronous replication, again, the client is making this write to the database, and then it commits to the primary. It's going to be replicated to the standby database. It's committed there. And then finally, that client's going to get an acknowledgement that everything is good. And one point here you could see of the behavior of this, it's a lot more latency, right? It's taking longer to have that transaction go through all the data stores, commit, and get that acknowledgement. And when you're talking about two regions or maybe even more that are geographically dispersed, this is orders of magnitude more latency that the application has to be willing to tolerate than in an asynchronous replication technology. And then the failure mode's a little different, right? So the client writes that transaction or sends a transaction to database. It's going to be, replication is going to be broken for some reason. And what you're going to result in is that acknowledgement is never going to happen, right? Because for synchronous replication, it needs to be committed to both of those data stores. So now you're getting a scenario where to the client, this application is unavailable. So you're creating shared fate between your regions, potentially in this. And there are things you can do. You can have maybe multiple regions and have a quorum-forming technology with your data store where you need 2 out of 3 writes to have some type of quorum, and then you'll acknowledge that transaction. But this is a behavior we have to think about in our application. Not many applications can just, right off the bat, accept this type of latency that's involved with synchronous replication. And then also, we need to think about how we handle these failure modes where we are dependent on that transaction being committed to multiple data stores. The other part of understanding the data is access patterns. And Barry will go into this in great detail about how they thought about this and reasoned about it at Vanguard. But in general, we need to understand our application. Is it a write-heavy application, read-heavy application, some combination of both? And also think about like the seasonality or like the timing of these access behaviors. Is it a certain time of the day, which Barry will talk about? Is it a certain time of the month, the year, et cetera, where one pattern kind of exhibits itself over others? And that is going to have an implication on the multi-region architecture you use. For example, if you're that first example where it's a very read-heavy application and stateless in nature, you can have a pretty quote-unquote easy multi-region active architecture with not much to think about. But when you get to the farther end of the spectrum where it's both read-intensive or write-intensive, that's where we have to start thinking about the trade-offs of asynchronous replication, synchronous replication, how we're going to have this consistency and availability where we might do like a read local, write global strategy or different kind of patterns that Neeraj will talk about. So the next one is fundamental 3 is understanding the dependencies. And first and foremost, if you're thinking about expanding to other regions, first look to make sure that the services you want to use are available in that region. 9 times out of 10, you'll be fine. I did have one customer that was looking to use another region and it was dependent on a service and it just wasn't available there, so we had to rethink our strategy a little bit. And the second part of this is look at the services you're using and see if there's some features there that have cross-region or multi-region functionality out of the box. And my mind always goes to like DynamoDB global tables or Aurora global database, but basically areas that take the lifting from your engineering teams and put it onto us and our services to handle some of those cross-region features for you. Now, the next one, and I find this the most interesting, and from talking with customers, this is one we spend a lot of time on, is understanding your internal and third-party dependencies. So we build out our application in a standby region. Say we have this third-party dependency. One that came up recently was like a payment transaction processing third-party. And the customer wanted to build this multi-region architecture, but was using this one endpoint from the third party to do payment processing. And we started talking about it. I'm like, we could do this multi-region. We could, our application can be very resilient. We'll be able to fail over in short order. But if something happens at a third party, we're still, we're out of commission. So if we're truly doing multi-region for resilience, we have to look holistically at all of our dependencies, and not just our app, but what is our app dependent on? And so if in this case, what we ended up doing was saying like, hey, is there another third party that can provide similar functionality, and we can incorporate that into our application? And this is another kind of point or gotcha. When you add, say, like another third party that's performing a similar function, we don't want to use it just say for that standby region, right? And we want to think about how we can create like a normal operating mode where we're actively using both of these endpoints and both of these third parties. Can we send 50% of my transactions to one, 50% of my transactions to the other? So that way we're normally exercising all of our dependencies, and it's not this kind of bimodal operation where when we run in the standby, it's a completely different operating mode that we're not used to and haven't really experienced. And then the same is true for any on-prem dependencies. I presume some folks here have on-prem dependencies for their workloads. I see some hands, some heads nodding. And so one thing that commonly comes up here is latency. And just to call out, like when we're talking about multi-regions, really multiple areas where latency manifests itself and how we handle that latency. And this is one area where it definitely creeps in. And most enterprises that I work with have picked their primary region because it has some kind of locality or basically located near their data center or colos. And then when you pick your standby, just by nature, it's farther away. So what happens is with the primary region in your application, you're used to pretty decent latency or low latency interactions between your dependencies on-prem and your application. And then when you run out of your standby region, the latency increases by some order of magnitude that is just not what you're used to from your primary region. And so you need to think about this and how you design your applications. And I've very rarely seen just an application that has been built and running in a single region just go to a multi-region. There's typically some re-engineering that needs to be done to factor in latencies like this or latency from, say, synchronous replication. And the same is true for a third party. AWS is a big cloud provider, and it's very possible that that third party is operating out of the same region that is your primary. So all of a sudden, if you're running out of your standby region, you may experience longer latency with a third-party dependency than you initially were. So these things have to be thought through and understand how or what are these implications of how these dependencies operate under this new kind of modality of multi-region. And then the last one is we don't want to take any dependencies from the primary to standby. Every time we talk to customers, multi-region is all about how can I create an isolated environment or stack of my workload that is completely independent and I can operate, if I'm having, whether it's self-inflicted of bad code deployment or if AWS service is having a bad day, how can I continue to operate with no dependency between those regions? And that's a critical point that we'll want to make sure that they operate independently of one another. The next one is the failover mechanism, and really the failover mechanism could be an architecture in and of itself. And the main point is we do not want to take a dependency on our primary region for failover. So we want to be able to enact that failover process from our standby region. And what this really involves is looking at whatever is part of your failover mechanism and thinking about, how could this not work as I expect? And then figuring out how, and if we need to, re-architect the solution to make sure it's completely independent and that I'm able to shift traffic when I need to and orchestrate my failover. And one tool we have at AWS, and I briefly called it out, is Route 53 Application Recovery Controller. So that's a purpose-built service to do just this. So we provide 5 regional endpoints that you can use to safely and confidently trigger a failover without taking a dependency on your primary region. So that takes us to fundamental 4, operational readiness. And the first one is just really, typically what I see is customers start in a single region and then expand to multi-region. And at that point, you've increased your service quotas and have used the service quota tool or created a support case, what have you, to raise your limits. And then now you need to essentially have parity for those services of your workload from a quotas perspective in that secondary region or standby region. So that's number one. The second is thinking about IAM permissions. IAM being a global service, if you're sharing roles between region, there's a potential shared fate there, right? If you make a change to a policy that is not as you intended, you could potentially impact both of your regional implementations. So thinking about how you can create specific IAM principles and roles, et cetera, in each of your regions. And the last one is service control policies. So a lot of organizations use SCPs to allow certain services to be used within an account in specific regions. So making sure that the services you want to use are available and activated is another thing. So next one's deployment. You never want to deploy to both of your regions at the same time, right? Again, we want to minimize any correlated or shared fate between these. So keep doing the things we're doing in region, whether it's a blue-green deployment or a canary. Do that in the primary region, get the infrastructure in a healthy state, get the code in a healthy state. Allow time for bacon, make sure that the application's running, accepting normal traffic for a certain period of time. And once it's all good, take that to the secondary region and follow that same strategy. And the next one is monitoring and observability. So the main thing here is we want to think about what metrics to replicate, and typically these are more higher order metrics such as user experience metrics, user count, transaction, and kind of metrics. And then also a new metric that you really didn't care about in a single region around replication lag, right? We want to make sure that we understand how far behind data synchronization is between our primary and standby. And we also want to monitor the health of the application in our primary region or region A from region B. We want like an outside a view of the health of that application. And really this telemetry will be useful in helping understand the health and be an input for that failover decision process. And then we go to people and process. So Barry will touch on this, but far too often I see, and just bluntly, an untested DR strategy is not a DR strategy. We want to get to the point where we are actively testing out this implementation. And even so, that maybe certain times of the year or every month or maybe even frequently every couple of weeks, we're operating out of that that standby region. And then we want to think about scope of failover. So this gets more complex in a microservice architecture, but we need to decide, do we allow teams to fail over independently? And the challenge that manifests in, again, is latency, right? So you have this kind of modal operation where maybe all these microservices were operating out of that primary region, and a couple of them decide to fail over for one reason or another. And now you have this kind of cross-region calls going back and forth. And maybe one cross-region call doesn't materially impact the workload, but multiply that by 10, 20. And now you're going to see, again, a manifestation of increased latency in that application. And can your workload tolerate that? So the other option is, how do we look at our workload and figure out what's required to perform a business capability? And for Amazon.com, that may be like the checkout functionality, right? And maybe 20 microservices or something like that comprise of that functionality. And let's fail over those in a coordinated manner so all of the calls will then be isolated to that region. And kind of going back to the previous slide, we don't want to create any shared fate between those regions. And the last part is we need to define not only like the automation, how we do failover, but the decision framework for enacting failover. Typically, in an organization, it's a select few individuals that are making that call of, hey, we're failing over this application. And we need to be very clear on that decision framework so we're comfortable and ready to enact that failover when we need to. And the last slide I want to touch on is just cost and complexity. Like I mentioned in my first fundamental of requirements, there's a lot of engineering effort involved. It's very rare that you could just take an application that was built for a single region and deploy that into a multi-region environment. There's operational overhead of the people, the process. You need to modify your pipelines to deploy to multiple regions. You need to have these processes for failing over and testing failover regularly. And then cost. You'll see that it's more than just infrastructure cost. In these kind of low RPO and low RTO scenarios, you're typically seeing like double the cost of having your infrastructure ready to handle that traffic at a short order. But then you also have the increased operational effort and engineering effort, which may mean, hey, we're not going to be able to build some features for the business because we have to actually re-engineer and architect for multi-region. So we got to weigh all of this against these cost and complexity requirements to make sure we're doing it for the right reasons. So with that, I'm going to pass it over to Barry to talk about Vanguard's multi-region strategy. Thank you, sir.
Thank you, John.
Thank you.
So my name is Barry Sheward, and I've been implementing and designing multi-region solutions at Vanguard for a few years now. For those of you that aren't aware, Vanguard is one of the largest investment companies in the world. It was founded in 1975 in Valley Forge, Pennsylvania, and that actually shows great forethought because it puts us almost directly between Wall Street and the AWS US East 1 region. So my role is the Global Head of Investment and Financial Cloud Architecture. What that means is that if you're familiar with any of Vanguard's websites, you might have been to our public retail website where you can buy your mutual funds. That's not what I deal with at all. I support our portfolio managers and our traders that are actually responsible for our front, middle, and back end operations, and they are located in Australia, the UK, and the US East Coast. So, as John mentioned, the most important thing is understanding your requirements. For a few years now, we've wanted to improve the user experience. We've been in the situation where we've tried caching, we've tried global file systems, we've done VDI, and we've done application streaming. And they've all helped to a certain extent, but nothing quite compares to the benefit you can get from moving compute and data closer to your customers. The other thing that we wanted is high availability. And we're not talking about disaster recovery here. We didn't want a failure to cause an outage that we could recover from. We wanted failures to have an insignificant impact on our users. And whether we achieved that, I think, whether it's a significant or insignificant impact, we'll talk about that more later. So the next step that John mentioned was understanding the data. We looked at our various workloads, and we came up with a number of different patterns, and I'm going to cover two of those today. The first is hub and spoke. It's a centralized model. So for example, we have a risk management team that runs a bunch of calculations, and those calculations are distributed around the world and used in multiple locations. The team in the centralized location in the US makes the updates every day, and they just get moved out. One of the other patterns we deal with is what we call the follow the sun pattern. So we have traders who work across the globe to execute these trades. So we'll start off with the traders in Australia who come in at the beginning of their working day. They want fast read and write access to the data so they can perform those trades. As the sun moves around the globe, we move to the UK. The traders there come online. They want fast read and write access to the data. And then later on during the day, as the sun moves across further, the US comes online and they want fast read and write access to the data as well. This is why we call that the follow the sun pattern. We learned some other interesting things about our data as well. Firstly, that some of our data doesn't change between start of day and end of day. And suddenly that takes a huge amount of pressure off. And the other thing we learned is that often our data changes according to these very workday specific intervals depending on where the sun is during those days. These two particular patterns, we refer to these as our primary, secondary patterns. And the reason is that they will work as long as we have a region that can be the primary and replicate out, these patterns will work. Which means that the patterns work with the Amazon Aurora database, right? Amazon Aurora Global Database is naturally a primary, secondary database. So we write to one region and it replicates out. DynamoDB is a multi-primary database. That gives us a lot more options. We could write to multiple regions at the same time. But one of the things that keeps me up at night is data conflicts and data consistency. So what we actually do is use a microservice, build a bounded context around our data stores, and use the microservice to enforce a primary, secondary pattern even on DynamoDB when we're using Follow the Sun or Hub and Spoke. Let's look at how things actually fit together with the Hub and Spoke model. You can see in this diagram, the hub, or the primary, is the US, and the pink line that you can see is the replication that happens out to the spokes, the secondary regions in the EU and Australia. The small blue arrows are the read access. So you can see from this diagram that every region has fast local read access to the data. In the case of the US, the solid yellow line means that it has direct write access to that data. And in the EU and Australia, if they need to write, they would follow the dotted yellow line pattern. They write to the local microservices, and those microservices understand that they are the secondaries, and they will forward the writes back to the US where they'll be written. And that means that we don't have write conflicts. If you can imagine, when Vanguard traders and portfolio managers are working, when we put something into a data store, say, for example, we want to buy 100 shares of Amazon. If we do that in two different regions, with DynamoDB, the last writer wins. We might end up with 100 more shares, we might end up with 200 more shares, and if this is a heavily loaded system, we're buying lots of shares, it's very difficult to detect where we are in the overall flow. Have we had any conflicts? So this is why we impose this primary, secondary pattern even on DynamoDB. The next step was switchable hubs. So you can see from the diagram here, we've moved the primary or the hub region from the US to Australia. Now it's Australia that's replicating the data out to the EU and the US. Again, everyone still has fast local read access. But if the US or EU need to write to the data, again, those writes will be forwarded off across to Australia and they'll be made there. No conflicts. For DynamoDB, we don't actually have to do a planned failover. All we have to do is tell the microservices, hey, you're now the primary, and they will allow writes there. With Aurora, we actually have to do a planned failover so that Aurora understands that a new region is the primary region. So in terms of failure, if the US region is down, we tell the applications in the US that they now need to write to the EU and read from the EU. In the past, before we had the multi-region, if we didn't opt for out of region, there would have been an outage in the US, right? That's a significant impact. I would consider this an insignificant impact. Latency is worse. It's not an optimal experience for the users in the US, but they are able to continue to run. And our business model, we often have staff in the US, or sorry, in Europe or Australia that can pick the work up and continue to work. EU is also in the primary region. They can write directly, but again, we're writing to a single primary, so we don't get conflicts. And if Australia need to make updates, again, the writes can be forwarded across to the EU, and then those changes replicated back to Australia. So let's talk about some dependencies here. Our third-party dependencies, we often have companies that provide data to us using AWS Transfer for SFTP or Amazon S3. So what we've done is set up AWS Transfer for SFTP in 2 different regions, and then put a Route 53 failover routing on top of that, and given our vendors a single URL. They're able to write to that URL, and it will go to one of those 2 regions. And the AWS Transfer for SFTP service will then write into the S3 bucket, and that data will be replicated around the world. And we do that instantly, because what we don't want is the situation where our data provider thinks that we've got the data, but then after that, the service has gone offline before we've had a chance to replicate it. We also have some data providers who are also Amazon customers who will write directly to our S3 buckets. Rather than give them a regional bucket name that enables them to write to the bucket in one specific region, we've started giving them multi-region access points. So they can write to the multi-region access point, and AWS does the work of ensuring that that write goes to the most appropriate region that's available. Again, once that data gets into a bucket in a region, we replicate it around the world so we can guarantee that we've got it and we can continue to process that data anywhere. Let's talk about how we handle these dependencies. So in order for our applications to work, you may have seen that they actually need to be aware of whether they are the primary or the secondary. If they're the secondary, they need to be able to forward the data, forward the writes to another region. So how do we actually achieve that? We came up with this model. We have teams building microservices, and obviously we want them to be involved in the work of creating new value for the business, not building multi-region solutions themselves. So what we've done is we've taken all the complexity associated with building a multi-region solution and moved that into one core component that we call Ghost, the Global Orchestration and Status Tool. Ghost maintains global state, application state, and also manages orchestration for us. So for example, if we need to recover from an unplanned Aurora failover, Ghost will be the tool that handles that. So that teams didn't need to figure out how to interact with Ghost themselves, we built something called GMRlib. We have versions for Java, Python, Node.js, and we're starting to work on Go now. What this library does is tell Ghost every so often, hey, I'm alive, and here's some data about my environment. What we're trying to do is provide global state to Ghost so that it can make intelligent decisions at some point in time, and at the very least right now, enable people to make decisions about which regions should be active or not. The response from Ghost is a message that goes back saying, that's great that you're alive, here is your primary region, here are your secondary regions, and at these specific times, your primary region will change. And that gives the microservices a heads up that things will change. If they don't get a message in time, they're at least aware of what the state of the system should be in the future. So it's great that applications now know who is the primary and who are the secondary, but how do we deal with that? What we've done is separate the definition of operations from the execution. By doing that, when we deploy these applications, microservices around the world, we end up with applications anywhere that understand what an operation should do. When a microservice needs to actually perform an operation, let's say it's a write operation, it will call the run named operation call and provide the data and the name of the operation, and then GMRlib can take over. What it has then is enough information to be able to make a number of different decisions. If we're in the middle of a planned failover, if we're doing follow the sun, it could buffer those operations for a minute and then replay them. If there's a failure, it can do a retry. And if it is not the primary, and that write needs to be forwarded somewhere else, it knows that if it forwards the name and the data to another region, the microservice there has got everything that it needs to be able to execute that same operation there. So we have built our follow the sun model and our ability to do write forwarding. From an operational readiness perspective, John mentioned a couple of times, An untested DR strategy is no DR strategy. So what we want is to test all the time. And if we can build that into the standard operating procedure of something, then you get that for free. And Follow the Sun does that for us. So let's talk about the different stages that we went through in terms of operational readiness. By building hub and spoke, we got some availability. We're still susceptible to the hub failing at that point, but we still have readability. When we went to switchable hubs, we solved that gap. If the hub goes down, we simply make another system the hub, and we can continue to work. With Follow the Sun, we actually test that 3 times a day. So we can be really confident that it's going to work when we need it to. We've just built in anomaly detection into the GMR library and Ghost. So for example, if one microservice says, hey, I'm the secondary, I'm going to forward this request to the primary, and the recipient of that says, I'm not the primary, something else is the primary, that's actually a really good indication to us that there is some kind of problem in the global state of the system. There's some messages not getting around somewhere. What we're working on is application state injection from Ghost so that we can actually deliberately tell these microservices conflicting information just to watch how they react. How do they forward messages around the system? So we have the ability to inject failure into the system in order to test it. So what do we get from this? Improved resiliency. We're able to function if 1 or even 2 regions out of our 3 go down. We get an improved user experience because every region has fast local write access, and the primary region, which is the region that is most likely to need to do the writes at any point in time, also has fast write access to the data. Right? So the hub region in the hub and spoke, or the traders that are actually trading during their workday in the Follow the Sun model. And we've also eliminated single points of failure with our third-party providers. No matter where they're running, they can get their data to us. In terms of costs, they have increased. And this comes up, people ask me all the time, hey, this seems like it's going to be an expensive solution. And we are typically running twice as much infrastructure as we would otherwise. But from a business case perspective, if we can avoid one single incident by having this infrastructure, it will actually pay for all of the infrastructure for the life of our systems. In summary, global multi-region is difficult, right? You need to have a reason to do it. Understand the requirements. We wanted to ensure that we had user experience and availability. We also, from our perspective, we don't have to worry about GDPR and PII because it's all investment data and it's owned by Vanguard. Understand business processes because there are some things where you have the potential to write a complex technical solution to a problem, but instead someone could pick up a phone and you don't need to build a complex technical solution. Understand the data, who changes what, where, and when. And once you understand that, you can determine the types of data stores that you can use that will support that. So understanding the technical limitations is also important. Things like if we went away from primary, secondary, Aurora wouldn't have been a fit. It fits for this particular case. Understand your dependencies, because no matter how much you build your infrastructure out, the data distribution patterns that you've seen, the hub and spoke and the Follow the Sun, none of that matters if the data can't get into our systems because our vendors can't get it to us. Set user expectations, right? I had people say, hey, if the US fails, there's going to be increased latency. Yes, there will be increased latency, but you'll be able to carry on working. And finally, prepare and test. Build observability into the system, test it, and if possible, make that testing part of the standard operating model. So with that, thank you very much. I've explained some of Vanguard's multi-region architectural patterns. I'm now going to pass you over to Neeraj.
Thank you, Barry, and hello, everyone. Welcome to re:Invent 2022. Welcome to this session. My name is Neeraj Kumar. Like John, I'm also from AWS. I'm a principal architect. My focus is on resilience on my day-to-day job. So John covered some of the fundamentals, some of the very foundational things we should be thinking and considering before we decide to go multi-region. Barry showed us a very concrete and real example of how Vanguard is reasoning and developing and going down that multi-region path. For this last segment in the presentation, we're going to zoom out a little bit and look at what are the other broader patterns that you can think and reason about before you go down the multi-region path. Now, at a macro level, there are really two ways to think about multi-region. You either want to do active-passive, which implies that you are using one region at any point in time where all the users, all your read and write transactions go to one primary region, and you have a passive or standby region. In case your services are impaired in the primary region, you can fail over and fail back. So that's the primary motivation. We'll cover more in detail on the next slide on this pattern. And the other one is active-active. Again, there are many different ways of doing active-active, but what it implies is you are using more than one region, two or more regions, even in some cases, depending on the workload and specifically like example Barry shared, if you have a globally distributed workload, in active-active architectures, you're using multiple regions at the same time. Of course, it comes in different, different sub-patterns. We'll walk through each with different drivers, but also different sets of complexities. And we'll see how some of the fundamentals that John talked about, the CAP theorem, the data access patterns, the data consistency come into play in these patterns. So active-passive, as I said, the motivation here, or the typical use cases here could be you need some kind of regional failover strategy. This could be part of your DR, your operational continuity processes. Also, this could be driven in part by regulatory needs that you may have. In this pattern, your key consideration, again, I will emphasize again, both John and Barry covered this, observability. We need to be able to know when to trigger our failover mechanisms, our failover procedures. So having shallow health checks, deep health checks, we have to be very mindful of those and the monitoring that goes with it for us to be able to get the signals we need really to kind of have very deterministically make these DR or failover steps. The other thing is when you're deploying workload cross-region, I know John briefly covered this as well, think about your deployment strategy. How are you going to ensure that your code, your infrastructure, your configuration has consistency between the two regions? So you have to think about how you're going to do your deployment pipelines, so your CI/CD pipelines. The next one is the routing strategy. This is where application recovery controller, which is part of Route 53 service, could become very helpful. It can help not just from a routing perspective, it provides you capabilities like doing the checks on your target region, the readiness checks to make sure that you're ready to fail over. So it could be very useful as part of that. And also your failover, failback procedures. Having your run books, having these as much as automated way you can do that, to have that predictability and confidence that when you are actually failing over, it will work as intended, as predicted. Also, active-passive you can deploy in, like as you can see in the subtitle of this pattern, like you can have a pilot light, which is the case where you have all your configuration code infrastructure available in the secondary region. And when you actually fail over, you bring your compute resources up and you make that capacity available to start taking the traffic in the secondary region. The other one is warm standby. In that pattern, it's kind of building up on the pilot light where you have some warm capacity already available in the secondary region. So in case you have to fail over, you can start serving the traffic and then kind of scale up from there. Active hot standby is the next step up from there where you're running pretty much like identical infrastructure and capacity in the secondary region as your primary region. And really the choice here based on pilot light, warm standby, or active hot standby will be based on what kind of RT, your recovery time objective you're trying to achieve. How quickly you want the traffic to fail over. The other key consideration is, as you can see, the data replication. John went into the depth of this. If you're using something like Amazon Aurora Global Databases, it provides you that capability where you can deploy your database across the regions. Of course, in this case, the data will be syncing asynchronously. It's an asynchronous replication. Of course, that's one way. Depending on which strategy you choose, you can also start with a backup and restore strategy. You simply backup from your primary regions and make them readily available in your secondary regions. So again, the choice between whether you do continuous replication or you do backup and restore kind of strategy will be driven by your RPO requirements, like where your recovery point objectives are as part of your business continuity strategy. Now, active-active is where things get a little interesting. So this could be the case where maybe you're trying to achieve really extremely high level of availability, or you may have the performance needs. Some of this Barry touched upon in Vanguard use case as well. You want the users in the close proximity of where that workload is. So that could be one motivation here. And also this could be driven by extremely low RT and RPO kind of situations. Now, active-active, there's no one way of doing active-active. So next few slides, we're going to look at what are the different ways to kind of reason about this. So one strategy could be regional sharding. What this means is your users are getting mapped to their respective regions. This could be an example of, say, globally distributed workload where you may have users in Europe using, say, London, Dublin, or any other European region, and the same thing here in the US. US-based users could go to US East 1. And there's no data replication going on between the region because we are really trying to isolate and map users to their home regions. And in part, this could also be driven by data locality requirements. You may have regulatory needs to keep your users and their data in their respective region. And of course, performance can also play in here with the close proximity with the users. The design consideration in this pattern remains the same as before. We still have to think hard about the observability, how the system is behaving, and your deployment strategy, because even in this case, we want to make sure application experience is consistent, and also how you're going to route the user between the regions. We'll dive a little deeper on the routing strategy later on. The next pattern is, again, this is similar to what Barry touched upon as well, that you are now having a single writer and multiple readers. So in this pattern, your users will always go to one region to write the transaction. But you can spread the read transactions across different regions. Again, this could be driven by, in some part, latency. Again, think of the geographically distributed workload. Or if you have read-heavy along with the latency sensitivity in your workload, that could be another use case where this could be helpful. Again, in this pattern, we are talking about eventual consistency. So think about can your workload sustain whatever that lag, replication lag is, which will be there when you're, even in case of Aurora Global Database, or if you choose to use any other relational database, there will be that replication lag that you need to think about whether your application can sustain that. The key design consideration, again, similar as before, but now you have to, similar to active passive, you have to think about some failure modes here, like what happens if there's an impairment on the writer, because you have a single writer. How do you recover and failover from a writer failures? And as I said, what kind of read after write consistency you're looking for. So that's going to be your another design consideration before you consider this pattern. Another variation of this pattern is you can actually instrument and engineer strong consistency between the regions. But John talked about this. I will say put a little caution on this pattern. If not done for the right reasons and right use cases and in right way, this can cause problems. It can introduce some different kind of failure modes. And one particular concern here will be around latency as well. Because with the synchronous write, if you remember the slide John shared, and depending on how apart these regions are, you are introducing an added latency, and that again may or may not work for certain workloads. So you have to be careful, like what your primary motivation is here. Going back to the CAP theorem, of course, what you're achieving here is very high degree of consistency, but your partition tolerance is something you need to think about, and the availability based on this strong dependency now we are introducing between the regions. And in terms of the motivation, why you may want to think about this. So specifically in the cases where you may have RPO near zero kind of requirements, and again, in part could be because of the regulatory needs. This is the pattern you could think about. But again, with all the caveats that we have called out. Now, another way to achieve strong consistency in multi-region could be you write dual writes. In this case, you've taken that complexity of writing synchronously from region A to region B. However, you have taken other type of complexity in this case. Now, the complexity here is the whole logic around data atomicity. How do you ensure the consistency of data in both region? Now comes down to the logic that you're writing in your application itself. So the client-side logic, you'll have to instrument that within that code to make sure you're able to achieve that. So managing data atomicity, that's like the primary concern here from a design perspective. The other one is data idempotency. This might be a scenario where if, let's say, one of the regions have some kind of a minor interruption and your application try to retry to write that same transaction more than once, you'll have to think about from an engineering standpoint, can your server-side code, your backend code deal with those situations? If the same transaction shows up again, how do you deal with that? So the idempotency becomes a kind of primary consideration here. And then finally, you can have multi-writers, multi-readers. In this case, you are distributing both your read and write traffic across different regions. This was briefly, I think, also mentioned in the Vanguard example. Now, in this case, again, the motivation could be very similar to some of the previous patterns for active-active. The added complexity or added concern here is how do you deal with the conflicts? Now, in case of DynamoDB, if you choose to use DynamoDB global tables, which can provide you this, the multi-writer and multi-reader functionality, it does actually take care of these conflicts with the last writer wins. But if you're building any distributed system yourself, and this stands true for any distributed system where you have multiple nodes that can take write traffic, you have to think about the conflict resolution, from a consistency perspective. And also in case of, even if you use DynamoDB global tables, it's still going to be asynchronous replication. So again, consistency comes here as well as a concern. What kind of consistency need you have? So if you need absolutely strong read after write consistency, that may not be the pattern you're thinking about. So we talked about routing, and we showed, like, of course, DNS-based routing and how application recovery controller can help you with the manageability of it, and give you really in a controlled manner. You can shift the traffic from your primary to secondary and all the other goodness that comes with it, readiness checks, etc. But that's not the only way to reason about routing, and specifically when you go in the active-active scenario, sometimes you may have some complex routing or some dynamic routing between the regions. So Amazon CloudFront, if you are already using it, it has a feature called Lambda at Edge. It's effectively a Lambda function that runs at points of presence at the edge, and it can do a few interesting things. So you can inspect the incoming cookies or the headers in the incoming request, or you can even inspect the HTTP codes that your server-side application is returning. And based on that, you can combine them to have some interesting routing patterns based on, of course, your application and how you're trying to map certain users to application stacks in different regions. So that could be helpful in those scenarios. The third one here is a global accelerator. It is one of our networking services. besides the routing, multi-region or even single-region routing, you also have an added advantage of some of the latency gains you can get with this. So with application global accelerator, you can accelerate the traffic because it traverses on AWS's backbone. So it's very quick to reach out to the different regions that you may be deploying your application in. And also it gives you a very fine-grained control on how you want to distribute the traffic across different endpoints across the regions. And you can dial the traffic up and down, and you can have a very different distribution styles for your traffic within a region or across the region. All right, so what are the key takeaways we want you to take from this session? And some of this you already heard Barry and John called out, but just to re-emphasize, if improving resilience is your primary goal, you don't have to start with multi-region. There's a lot we can do even within one region to improve the resiliency of your application. And we have some sessions going on this week. I would highly encourage to go and watch those sessions which talk about how you can improve resiliency in general in single region deployments as well. And also multi-region is not just a technology decision. It has to, Barry covered this in Vanguard example, you have to reason this based on the business value you're trying to drive by going multi-region. What kind of, you have to kind of weigh that compared to the complexity and the cost and the manageability that you take on board. How does it weigh against the business value you're trying to drive? So dependencies, again, I cannot emphasize enough, dependencies are super important for us to understand, and specifically in the context of going multi-region, we should avoid any kind of inter-region dependencies, because we are defeating the purpose of going multi-region in first place if we are introducing any of such dependencies and have the shared fate between the regions. And the next point is kind of building on that. So use regions what they're really designed for. They're designed intentionally to be isolated infrastructure. Again, observability, one of the key fundamental and foundational capability that John covered, it's very important, like in the context of multi-region or in the context of DR and operational continuity strategy. How do we even know we should trigger our failover mechanism, our failover runbooks, if we do not have those strong signals where we can deterministically make those steps? So really important to think about very early on. And finally, multi-region can be complex, depending on which pattern you choose to for your workload and for your use cases. So choose the right pattern that makes sense for your use case, your workload, and of course, do it for the right reasons. So I think with that, thank you everyone for coming to this session, and we'll appreciate the feedback after the session. So thank you very much.